All right, today we're going to take a look at two types of transformations. We're going to look at translations and reflections. First of all, just a couple of things as far as terminology that you may see. If you see the word pre-image, that's talking about the original, where it was originally. If you see the word image, that's talking about where it ends up, okay, after it has been transformed in some way. Today, again, we're going to talk about translations and reflections. The first one that we're going to look at is translations. You may have seen this before, but let's talk about what is a translation. A translation is a vertical or horizontal shift, or it could be both. So we're moving left, right, or up or down. I have an example here for you guys to take a look at. Given triangle ABC with vertices A, B, and C, translate this triangle left 4 units and up 3 units. So let's think about what's happening here. If we're going to the left, what are we doing to the x-coordinate? If we move to the left, the x-coordinate has to be reduced by a certain amount of number, in this case 4. If we're moving up 3 units, then the y-coordinate is the one that's changing. So we're going to have to add 3 to the y-coordinate because we're moving up. So let's write out our new coordinates for A, B, and C. Get a pen. Here we go. So A, let's think about what we said is happening. We're going to add 4 to the x's, or excuse me, subtract 4 from the x's and add 3 to the y's. So I'm just going to make a little note for us out here. We're going to subtract 4 from the x's and we're going to add 3 to the y's. Okay, so our new coordinates for A are now going to be 0 minus 4 is -4, 0 plus 3 is 3, so -4, 3. New coordinates for B, 3 minus 4 gives us -1, 1 plus 3 gives us 4, so new coordinates for B are -1, 4. And C started at 5, -2. New coordinates are going to be 5 minus 4 is 1. And -2 plus 3 is 1, so C is now going to be at 1, 1. Okay. And then I said graph both the triangles, the original and the transformed triangle. If you take a look at that picture out there, I already have that for you. The original triangle started out as the one in red, and then the transformed new triangle with our new coordinates is the blue one. So you can see the shape stayed exactly the same. It just shifted from one place to the other. Translation is, excuse me, one of our transformations that preserves size. So the size of the figure stays the same. It does not change. It's just shifted left or right or up or down. All right, let's take a look at another one. Translate quadrilateral WXYZ, 3 units right and 2 units up. So again, let's talk about what's going to happen to our coordinates. If we're moving 3 units to the right, then that's affecting our x-coordinate. We're moving to the right, so we're going to add to our x-coordinate. So we're going to add 3 to our x-coordinates, and then let's talk about moving 2 units up. That's going to affect our y-coordinate. We're going up, we're going to add. So we're going to have y plus 2. Now let's do these for our new points. Let's start with W. So our new coordinates for W after this translation, we want to add 3 to the x. -2 plus 3 gives us 1. Add 2 to the y. 3 plus 2 gives us 5. So the new W is at 1, 5. X. We want to add 3 to the x. 2 plus 3 gives us 5. Add 2 to the y. 4 plus 2 gives us 6. The new coordinates for y. 1 plus 3 gives us 4 for the x. -2 plus 2 gives us 0 for the y. Now, our new coordinates for z. -4 plus 3 gives us -1 for the x. -4 plus 2 gives us -2 for the y. And I have the graphs of both of these out here for you to take a look at. The original, we had the coordinates -2, 3, 2, 4, 1, -2, and -4, -4. That is your figure in red. And then our new coordinates that we just found are in blue. Okay, again, the translations preserve the size. The size is the same. It's just shifted left, right, or up or down. All right, here's one that's a little bit different. Describe the translation from triangle ABC to triangle A prime, B prime, C prime using coordinate notation. Okay, let me go back for just a second. Using coordinate notation, take a look at what we did when we wrote these out. Notice how we said x plus 3, y plus 2. For the second example, we said x minus 4, y plus 3. That is your coordinate notation. You're telling it what you did. You took coordinates x, y, and what did we do to those coordinates? So let's take a look. Let's look at the original. Let's take a look at for example, point C. Point C moved from, what is this, 3, 5 to 7, -4. So let's think about what had to happen. We started out at, let's look at the x's. We started out at 3 and we ended up at 7. Okay, so we had to add 4 to our x's. Okay, let's take a look at our y coordinates. We started out at 5 and we ended up at -4. So to go from 5 to -4, we had to move down 9 units. So we're subtracting 9 units from our y. So this is coordinate notation. We're saying that we started out with an xy coordinate, and then we added 4 to that x, and we subtracted 9 from that y to get our new coordinates to do this translation. All right, let's talk about reflections. Okay, what is reflection? A lot of time when you hear the word reflection, you think of your reflection in the mirror. Okay, reflections flip something over a line. It creates a mirror image with respect to the line that you reflect over. Okay, we have some rules. There are 4 that we use pretty regularly. Reflecting over the x-axis, you negate the y coordinates. To reflect over the y-axis, you negate the x coordinates. To reflect over the line y equals x, you switch the x and y coordinates. And to reflect over the line y equals -x, you switch the x and y coordinates and you change their signs. Okay, let's draw a quick little picture so you can get this, kind of figure out what we're talking about. Let's say that we start out at the point 3, -3. Okay, if we were to flip this point over the x-axis, okay, think about, we are 3 units away from the x-axis, so if we flip over it, we're going to be 3 units away on the other side. So if we flip over the x-axis, we're going to be up here. Notice all we did was change the sign of the y coordinate. It was -3, now it is +3. Let's go back to our original, okay, that blue point over here. We're at 3, -3. Let's say we want to flip over the y-axis. Okay, so if we're going to flip over the y-axis, we are 3 units to the right of the y-axis. So now we want to go 3 units to the left of the y-axis in order to flip over. So now take a look at what happened. Our y coordinate stayed the same. We're still down at -3, but our x coordinate is the one that was flipped. We were at +3, now we're at -3. Okay, let's go back to that original point again. Let's see if I can get another color here. Go back to that original point that's in the blue. Let's talk about, let's draw that line. Let's draw the line y equals x. Okay, y equals x. Got a positive slope, goes to the origin. Okay, x and y coordinates are equal. So if we're going to flip over the line y equals x, okay, we've got the coordinates 3, -3. Think about flipping over this line. We're going to be the same distance on the other side, okay? What was 3, -3 is now becoming -3, +3. So we now have a point here. We switch the x and y coordinates in order to flip over that line. Okay, last one, we talked about the line y equals -x, which kind of cuts these two quadrants in half. We want to flip over that line with the original point. I apologize, we had an announcement at school. All right, let's flip over that line. Notice we're already on the line. The point 3, -3 is actually on the line y equals -x. So if we try to flip, we're going to be in the exact same place. Okay, and think about why. If we had the point, what did we say? We said our original point was negative 3. So if we want to flip over the line y equals negative x, our rule is to switch the coordinates and change their signs. So if we switch and move y to the x and change its sign, it becomes positive 3. If we move x to the y and change the sign, it becomes negative 3, and we end up with the same coordinate. These rules are ones you just want to remember. You can always draw a quick graph, but it's going to take you a while if you're doing a lot of points in order to draw a graph. So it's a lot easier to just kind of memorize these rules. All right, let's take a look at using these. Let's say we have a quadrilateral ABCD and then we have the coordinates and we want to flip it over the x-axis. We want to reflect this picture over the x-axis. So remember our rule that we just said, over the x-axis we want to negate the y-coordinates. So let's write out what our new ones would be. A, if we're going to change the sign of the y-coordinate, we keep the x as it is, and now we're going to change the sign of the y-coordinate, so we now have negative 1, negative 1. B, we want to keep the x as it is, and we want to negate the y, so now it becomes negative 4. C, we want to keep the x as a 4, just as it was, negate the y coordinate, becomes a negative 1. And then last one, D, keep the x as it is, a 1, and then we want to negate the y coordinate, but it's already 0, which isn't positive or negative, so it's going to stay 0. Notice that point 1, 0, it's already on the x-axis. So if we try to flip, we're just going to end up still in that same point on the x-axis. Notice that I've graphed the two figures here for you. The original one is in the red again, and then after we have reflected over the x-axis, we have this figure in the blue. All right. Here, we're going to do several different ones. We're going to do 2 different reflections. Okay, so we're going to start out with these 3 coordinates for RST. And in part A, we want to create a new triangle by reflecting over the line y equals x. So whenever we reflect over the line y equals x, we have to switch the coordinates. So our new R is going to be at the point 4, 3. Our new S is going to be at the point 6, 5. And our new T is going to be at the point negative 4, 4. Then we want to flip over the x-axis. So remember, to go over the x-axis, we have to negate the y-coordinate. So let's do that. Keep x the same, negate the y. Well, that's not this. There we go. S. Keep the x the same, negate the y. And then last coordinate, new T. Keep the x the same and negate the y coordinate. So these are our final coordinates. Notice I graphed all 3 of these here for us to take a look at. We started out at 3, 4, 5, 6. Excuse me. And 4, negative 4. So that is your picture in red, your triangle in red. Then we move to 4, 3, 6, 5, and negative 4, 4. That is your picture in blue. And then we move to the final image after we reflected over the x-axis. That is your image in green. All right, here's another one. We're going to put some stuff together now. We're going to do some of both. When we put more than one transformation together, those are called composite transformations. We're going to take a look at putting some translations and reflections together in this example. We're starting out with a triangle, and we have coordinates M, N, and P as our vertices. We want to first translate the triangle 2 units to the right and 3 units up. So let's think about what we're going to do there. If we're going 2 units to the right, we're going to have to add 2 to the x's. If we go 3 units up, we're going to have to add 3 to the y's. Then for part B, reflect this new triangle over the line y equals x. We said when we do that, we switch. So we're going to switch our x's and y's. And then part C, reflect this new triangle over the x-axis, so we will negate the y. Let's go through those. Let's start with part A. First, we want to translate 2 units right and 3 units up. So our new M, we're going to add 2 to the x, add 3 to the y, so that becomes 4, 6. Our new N, we want to do the same thing, add 2 to the x, add 3 to the y, so that becomes 1, 5, and then P, add 2 to X, add 3 to Y, and we end up with 3, 2. Part B, we want to reflect over the line Y equals X. So we're going to take these new points that we found in part A, and we're going to switch the X's and Y's. So the new M is 6, 4. The new N is 5, 1. And the new P is 2, 3. And then our last step, part C, we want to reflect over the x-axis. So we're going to take our points we found in part B and negate the y coordinates. So our new M is 6, negative 4. New N is 5, negative 1. And new P is 2, negative 3. Okay. Notice that I graphed the original in red, and then your final image for part C after you've done all of those in blue. And again, notice that the size of this picture has not changed. The size of the triangle did not change. Both translations and reflections preserve the size of the original. They do not change the size. All right. Let's take a look at this next one. If the algebraic rule for this transformation, notice it gives you what's called the image. Okay, so this is after a transformation has happened. If the algebraic rule for the transformation is xy goes to negative xy, determine the coordinates of the pre-image. So we're going to have to work backward. Okay, we want to find the pre-image. We want to find what it was originally. So let's find those original coordinates. Okay, we negated the x to get here, so we're going to negate the x to move back. 0 doesn't have a sign, so it stays 0. S, now the original coordinate would have been negative 4, 2. T, the original coordinate would have been negative 3, negative 2. And U, the original coordinate would have been positive 1, negative 2. Let's talk about the description. Part B, describe the transformation. Okay, when we negate our x's, that means we are flipping over the y-axis. So this is a reflection over the y-axis. Example 8 there, I'm not actually going to list out the coordinates. We could list out the coordinates if we wanted to for the image and the pre-image, but let's just take a look at the picture. Okay. First of all, we can tell this was not a translation. It's not facing the same way. So it wasn't just shifted up or down or left or right. It has flipped over, and notice that it has flipped over the x-axis. So part B, describe the transformation. This is a reflection over the x-axis. And then part C wants us to write the coordinate notation for the transformation. So let's think about what would happen. We would start with our coordinates x, y. Then if we flip over the x-axis, we always negate the y coordinates. So we keep the x the same and we negate the y. All right, last one. This is definitely something that people struggle with a little bit as far as reflection. So I wanted to make sure to take some time to look over this. We have the coordinate P, which starts out at 3, negative 2. We want to find the coordinates after P is reflected over the line x equals 1. That's the first thing we want to do. So I'm going to just make a little graph so I can show you visually what's happening here. We're starting out at 3, negative 2. Okay, so here's our point there. Now we want to reflect over the line x equals 1, which is a vertical line, vertical line going through x equals 1. Now let's think about where we are. We're at 3. We want to reflect over the line x equals 1. So we are 2 units away from that line. We're 2 units to the right of that line. We want to reflect over that line, so we're going to have to go 2 units in the other direction. We're going to go 2 units to the left of that line. So if we're starting out at 1 and we go 2 units to the left, we end up at negative 1. And now we flipped over that line. Our y-coordinate stayed the same. Our y-coordinate stayed negative 2. Our x-coordinate is the one that changed. Just like when we talked about a y-axis reflection, okay? Y's stay the same, but our x's are going to change. So now we're going to have the coordinate. Think about what we did. X was 3. When we flipped it over the line x equals 1, we went 2 units to the left to get -1 for our x, and our y stayed the same of -2. Let's take a look at the next one. Part B, we're going to find the coordinates after P is reflected over the line y equals 2. So we're going to start out in the same place that we did before. We're going to start out 3, -2. Now we're going to flip over the line y equals 2. Now y equals 2 is a horizontal line. So here's what we want to think about. We are now below this line. We are 1, 2, 3, 4 units below that line. So if we want to reflect over that line, we have to go the same amount of units in the other direction. So if we're 4 units below that line, we want to go 4 units above that line. So we're starting out at 2, and we want to go 4 units up. We're going to have to go all the way up here in order to reflect. So we started out at -2. We were 4 units away from the line y equals 2, so we had to go 4 units above that in the other direction. So 2 plus 4 gives us 6 for our new y coordinate. Notice our x coordinate stays the same. Our x coordinate is still 3. So our new point now is still 3 for the x coordinate, but now it is 6 for the y coordinate. So hopefully that helps you when you're reflecting these. If it helps you to draw a quick little picture for yourself, I would suggest you do that. A lot of times that can be extremely helpful just so you kind of know where things are in relation to each other. These are probably the hardest reflections that we do. And so a lot of times drawing that picture to kind of get an idea of where things are can help. If you're struggling with these type in particular, please feel free to reach out to me and I will help you figure out how to do them. I'll go through, I'll make a video, something for you so you can see me working through some of these problems.